Thank you. Okay, hello everybody. Thank you for the introduction. Yeah, so I'm Brendan Hernandez. The purpose of this presentation is to shed light on the concept of DevSecOps for Model as a Service. And with me presenting today will be Dr. Jay Simmons. So to start off, a little bit about myself. I'm currently a level 3 FTL systems engineer at Northrop Grumman, particularly in the space sector in the Launch Vehicles Division out here in Chandler, Arizona. I got my master's in aerospace engineering from Arizona State University, after which I immediately joined Northrop Grumman up in Sunnyvale, California, and spent 3 years up there, mainly dealing with the Navy and doing things with submarines, and did activities including analysis, test, as well as a little bit of systems engineering leadership. Following that, I joined our Future Technical Leaders program, which is a 3-year program, and you rotate once a year to different sites and just meet new people and network. So last year was my first rotation, and that was out in San Diego, California. I worked on the F-35. And then for the past few months, I've been out here in Chandler as the multidisciplinary design analysis and optimization solutions team lead. In my spare time, I enjoy camping with my brand new rooftop tent, which is very exciting. I like going boating and wakeboarding out at Lake Pleasant, and exploring the Phoenix area should really be exploring Arizona, because to escape the heat, I've been traveling up to northern Arizona a lot. As I said, with me presenting today is Dr. Jay Simmons. He is a systems engineering manager out here also in Chandler. He's had 15 years in the digital and systems engineering environment. He got his Ph.D. in space systems engineering from the Air Force Institute of Technology, and during those 15 years has worked with MNS automation and integration for MDAO, as well as implementing digital threads between MDAO and MBSE. In those 15 years, he's supported all corners of the aerospace industry, whether it be the government, the contractor side, or various labs. Okay, so to start, what is DevSecOps? Well, DevSecOps stands for Development, Security, and Operations, and it is an approach to implementing the product lifecycle for software. And we can use this approach with our analytic models because models are, in fact, software. Models are basically just very specialized pieces of software whose functionality is to use mathematics to predict the behavior of systems. So before we get too heavy into DevSecOps for Model as a Service, I wanted to just have one slide on the ModelCenter Integrate tool that we use, because it's very important to the Model as a Service concept. So ModelCenter Integrate is used by Northrop Grumman in Model as a Service. ModelCenter Integrate is a core package. The rest of the ModelCenter package is built upon this base integrate capability. Those ModelCenter Integrate capabilities are automating analytic models. This is the process of taking an existing model in any tool, whether it be Excel, MATLAB, Nastran, or in-house tools, and defining its inputs, its outputs, and how to execute the model, basically making it into a black box. And we'll get more on that in a moment. Integrating automated models into workflows, also known as a model of models. The integration defines data and order of execution relationship between models to ensure that when each model runs, it has the data it needs. And finally, executing integrated workflows in single runs or part of trait studies, like single dimensional parametric studies or designs of experiments. Okay, so let's get right into it. Model as a service. So ModelCenter Integrate, the tool we just spoke about, supports both local automation of models and publishing automated models onto networked servers for remote execution via Model as a Service. MaaS-hosted models only expose the black box automation of the models. Clients cannot access the underlying model definition or tools. They only see the exposed inputs, including bounds and other metadata to limit accepted data, exposed outputs, and permission to execute the model. There are tools to support authentication and access control for MaaS-hosted models. And any model that can be automated in ModelCenter Integrate, which is basically any model that runs in a tool with an API or that supports batch mode, can be hosted under MaaS. And here is why MaaS is a better solution to model sharing than sending models to coworkers and customers. So to start, MaaS provides access to run the models without having to give the models to consumers, both internal and external. The disciplines own their models, and the disciplines can regulate model execution through parameter bounds. So if your model only works between bound A and B for certain variables, you set that, you define it, and because it's black boxed up on a MaaS server, the users cannot go outside of those bounds. Model owners also control access. Access can be controlled by groups and users. The model visibility can be controlled by groups and users, and access can be turned on and off at any time. And then finally, model access is better than model distribution, and MaaS allows us to use model access as opposed to model distribution. So model owners, such as Northrop Grumman, retain the intellectual property, and customers can run models without the overhead of maintaining modeling environments. So because all of this is hosted on a remote server, the customer doesn't need all the tools and the computational power to run a model if they want to see what our model does. It's all on the remote server. Okay. And MaaS models can be accessed across the network, assuming the users have the correct access and permissions, of course, meaning models can be run from across the enterprise. Workflows can easily point to models shared on the digital thread from other teams, other sites, other sectors, or even our customers and suppliers if needed, all without exposing the model's underlying intellectual property. So this figure here shows that you can make a single workflow using models from all across the world. Model as a service provides access to analytic models without having to distribute the models themselves. That's really the bread and butter of model as a service. Okay, so let's get into what does DevSecOps for model as a service look like? Well, we've got our DevSecOps infinity symbol there, and we'll go through each of these steps for DevSecOps, beginning with the plan step. So in the planning stage, we need to establish engineering needs and goals. This involves stakeholders to understand all concerns, writing acceptance criteria, and defining requirements for new capability. Kind of the DevSecOps portion of this, or addition, is we need to define and plan work to achieve engineering needs and goals, and this should be done in an agile fashion for DevSecOps. Jira is usually the most common tool chosen for this. Once that is done, we prepare our workspace for our program needs. So we need to add repositories to store our models and our code. We need to choose the tools and the versions to meet our needs. And we need to ensure that all of our engineers are using a consistent workspace configuration. So once this baseline is kind of set, we can move on to the code stage. Now for software, this is where we write the actual code and test cases, and it's a little bit different for the modeling space. So in the modeling space, we begin by choosing the modeling tool we want to use. In the example shown on the screen, we chose MATLAB. And we write the model, so we do the actual work. In here, we wrote a MATLAB script called plots.m, so we have our model written. Once the model is up and running, we use ModelCenter Integrate to automate the model and black box it so we can put it up on Model as a Service. And while doing this, we can and should develop test cases to ensure the model runs as expected. So once we have coded and built our model, we go into the build stage. Now in software, this is where we compile the source code into the executable. And again, in modeling space, it's a little bit different. So picking up from the code step, we should now have a folder structure with automated model files and supporting files shown there on the left. Now, ModelCenter Integrate has a feature for publishing models called PackZ Publisher. Using this feature, we can bundle our automated model with all of its supporting files into one single file called a PackZ file. So now that we have our one single black box PackZ file, we move into the test stage. Now in software, this is where we run a regression test to ensure that newly written code works as expected, and it is actually the same for the modeling space. So for models, we can write test scripts that will test our model, ensuring best practices are followed during model development, test for things such as variable metadata, and we can also run trade studies to ensure the model outputs are as expected. Now that we've built our model, packaged it into a PackZ, tested our model, we can release it. So during the release step in software, it's where we determine if we meet the requirements to go into production, and it's the same for models. So using continuous integration, continuous delivery software such as Jenkins, we want to look at our test results and ensure all tests are passing. You can see in this example image at test number 65, finally all of our tests are passing. Although pipelines may differ, the part that we want to focus in on during this release stage is the approval step. This is where the person with the authority to approve the release of the model reviews test results and any other appropriate artifacts to make the go, no-go decision to release this version of the model into production. Once approved, we go into the deploy stage. Now in software, it's where we put our code up onto the server, and for models, it is basically the same thing. With models, the particulars are, we take the PackZ file that was built from the model files in the version control system and released in the previous step, and updating the deployed model on the MaaS server, which involves removing the old version of the model and adding the new version. Now this is achieved by setting up a pipeline using a CI/CD tool, again, such as Jenkins. Once a pipeline is verified, the automation the CI/CD tool provides us will greatly minimize downtime between model release and model deployment. Now, once deployed, this is where the users get their hands on the application. So in the operate stage for models, once deployed, the users can use the models on a regular basis. In ModelCenter, users can find the deployed models listed in the server browser. So if you have multiple servers or one server and multiple models on one server, they will all show up here in the server browser once you have linked it. Users can use these MaaS deployed models to build their workflow and create connections between the MaaS deployed models. Again, the workflow is like a model of models. And as a note, MaaS deployed models have URLs. Each has a specific URL. And those URLs will point to the access controlled remote servers directly. Okay, so finally we've gone through code, we've built, we've tested, we've released our model, we deployed it on the servers, people are using it, they're operating the models. So we move on to the monitor step. In software, this is where we observe the health and the status of our applications and respond appropriately when those applications require attention. It is very similar for models. The purpose of the monitor step is to ensure the integrity of the automated models and workflows. We want to maintain the availability of our models for use. We want to gather metrics, and we want to monitor for crashes, failures, things like that. Proper monitoring allows for real-time operations support and feedback to yield into future program planning. And that is the end, short and sweet. I'm open for questions. Are people still able to hear me? I open it up for questions. Brandon. It looks like, okay. Sorry if we missed it. We're going to the question phase.
There hasn't been any questions. For anyone that has any questions, please feel free to input them in the question panel.
So this is Kenny. So while folks are thinking about their questions and putting them in the question panel on the GoToWebinar, this topic really resonates with me, and I'm really excited about model as a service in cooperation with a DevSecOps methodology. I'm familiar with modeling environments like Cameo, sort of modeling sort of systems and simulations, where this might be more about code and code release. Do you have experience or examples that you can think of where, for example, system models, simulation models, analysis models, the kinds of things that you would see up front in the product development sort of design lifecycle benefits from this approach?
Yeah, thanks, Kenny. So all of these steps can be followed with, particularly in these examples, analytic models. If you're using MATLAB or a CAD program or in-house tools, anything like that, file input, output, text input, output, in-house tools, those can all follow these steps, be automated in ModelCenter, put out for release and deployed. And then Jay, I don't know if you wanted to take over an MBSE or Cameo specific example.
I'd be happy to. So this is, if you ask me, this is following this set of steps or something very, very similar so that we maintain rigor and quality of our analytic models is essential for establishing the analytic endpoints on the digital thread, because very frequently the architecture models, things that we would build in SysML or similar languages in Cameo, right? The information within them is either source material for inputs to our analytic models or is subject to the results of our analytic models. And we want to, as much as possible, enable that flow of data to be digital, to be automatically flowing, as opposed to someone having to read something with their eyes and type it in at a keyboard. to maintain and establish the digital thread. So there's actually a piece of the ModelCenter ecosystem called ModelCenter MDSE, which allows you to take model as a service hosted analytic models and integrate them into architecture models specifically to send data back and forth like I was describing. And tomorrow, I will also be talking about how we can apply DevSecOps approaches to our systems engineering activities in our architecture models. Does that cover the question?
Oh, yes, brilliantly. Wow, I can say that fast. Thank you, and great plug for tomorrow's agenda. This is super exciting, and thank you for that response.
Absolutely. Are you seeing the questions that are coming in on the questions panel now?
I am not.
Yeah, there's a couple of questions.
Yeah.
The first question is, did you cover access to customers or other programs? I'm assuming this probably has to do with maybe sharing models across or the pipeline itself.
I don't know if I have a great slide to put up for it, but yes, there's definitely access control, and that is done within the ModelCenter environment and like on a per server, per model basis. So you can control access to particular users or particular groups, and that does include internal and external customers. We didn't go into the nitty-gritty specifics because that's more of a ModelCenter and access control topic, but DevSecOps for Model as a Service absolutely has access control within it. That's one of the main, the key points, one of the main positives about it.
The other question we received was, how do you model lifecycle management at every single step of DevSecOps?
Jay, do you want to take this one?
Do you want me? Yeah, I was going to say, do you want me to take this? So my perception of this is that what we're really doing here when we look at this full process, the full DevSecOps lifecycle, is that this is our lifecycle management approach for models that we're proposing. In today's world, and as Brendan mentioned, I have been all over industry at one point or another, thanks mostly to my time at Phoenix Integration before I came to Northrop. And in my experience, a lot of model lifecycle management is either somewhere up on a shared drive with revision numbers and file names, or if you're lucky, has moved into version control systems, frequently SVN, and that's kind of where we are as an industry. Not quite the wild, wild west anymore, but not quite as rigorous and absolutely reliant on the expertise of our subject matter experts. And as we move into the digital thread, I would propose to all of us that we are now at a point where our models will get run by people other than us, and that has to be something we become comfortable with and our consumers become comfortable with, and that in order to reach that comfort, we have to start applying more rigor. And since models really are software, I don't think we have to reinvent the wheel here. I think it's absolutely incumbent upon us to leverage established methodologies wherever possible that are working for industry already. So hence the application of DevSecOps to our modeling space.
All right, thank you, Brandon. Is there any other further questions from the audience? Please feel free to ask them in the question panel. There's one more question that came in. Are you suggesting the same tool for model dev and model ops?
So I'm gonna go ahead and take this one. I think this is Jay again. If the question here is between dev and ops, for example, if the determination for the engineering need is I need to run a finite element analysis, and I have decided to use ANSYS as the tool to perform that analysis in, either because it's our standard tool in-house or it has some feature for this particular analysis that makes it particularly appropriate, or what have you, or maybe it's MSc NASTran or what have you, right? That the fact that I've built my model in that tool, right, obligates me to execute that model in that tool. The model is deeply tool specific. I can't run a MATLAB script in ANSYS, for example. I have to go get MATLAB. And similarly, I'm not going to run a NASTran deck through MATLAB or Cameo. I'm going to run it in the NASTran tool I built it in. So I absolutely have to deploy the analytic tool that I used for developing the model to my hosting server for Model as a Service. And then in terms of the Phoenix integration tool suite versus some other automation tool suite, again, this is kind of the equivalent of, as a software developer, if you choose Node.js as your development environment for your web application, you will absolutely be running Node.js on your development environment and on your operations on your production environment for the same, and it's the same kind of thing here. If we choose ModelCenter Integrate to create the black box automation around that ANSYS model or NASTran model or MATLAB model, I have to, again, continue that use into production the same way I would if I'm using React and Express and Node.js in a web development environment. I hope that answers the question.
I think that clears it up.
Excellent.
Is there any? Yep. So I'm not seeing any other further questions. I guess this is